Bismillahirrahmanirrahim. Assalamu alaikum, my YouTube students. Dear students, in my today's video, we are going to discuss some special types of the sets. First one, finite set, unit set, disjoint set, equivalent set, universal set, infinite set, empty set, overlapping set, and equal sets. We will discuss 9 types of sets. So let's go to the first type, that is finite set. A finite set is one in which it is possible to list and count all the number of all the member of the set. So finite set means that we can list down all the elements or we can count all the member of sets. In the finite set, all the elements or members of the set are countable. We can count all the members. For example, the first one is A is equal to days of week. So we can count, yes, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. There are 7 elements or members of the set which are countable. So this set is a finite set. Second one, D is first 4 odd numbers, means that 1, 3, 5, and 7 are the first 4 odd numbers. And the set B has 4 number of elements. So n of B is equal to 4. So it is also a finite set. Infinite set. A infinite set is one in which it is not possible to list and count all the member of the sets. It means that infinite set is having infinite number of elements. The number of elements which are not countable. For example, see set of odd numbers. They are not saying set of first 5 odd numbers, first 2 odd numbers, first 10 odd numbers, first 90 odd numbers. If they said write down first 5 odd numbers, so we know that first 5 odd numbers we have to write. So odd numbers we can count 1, 2, 3, 4, 5. We can count the number of elements. But here it is set of odd numbers. So unlimited odd numbers are there. So the set will be infinite. Or if they are saying or there the set B has infinite number of elements, so it is not possible to list down all the elements or count all the elements. So it is an infinite set. Another example of infinite set is number of stars on the sky. We cannot count all the stars. So it means it would be infinite as well. Set of natural numbers. Set of natural number is also infinite set as the number of elements are going on. Next one is empty set or null set. Empty set, as the name suggests, that empty set having no element, no member. So empty set will be empty. No element will be there. Empty set is denoted by just 2 empty curly braces or 5. Examples are H, number of dinosaurs on the earth. Then H will be, of course, an empty set as there is no dinosaur on the earth. Or we can say natural numbers between 1 and 2. This will also be an empty set as there is no natural number between 1 and 2. Next one is unit or singleton set. Singleton, as the name suggests, singleton means single element. So a set that contains one element or single element is called unit or singleton set. For example, A is equal to 10, or the natural number between 2 and 4. So it would be 3. So singleton element will be there. Disjoint set. Set which have no number in common. If we are discussing 2 sets and there will be no common element in between them, disjoint sets are those sets which are not having any single element common in between them. For example, if we are saying A is equal to 1, 2, 3 and B is equal to 4, 5, 6. So 1, 2, 3 and 4, 5, 6, there is nothing common in between 2 sets. So the intersection means the common one will be empty set. So their intersection means the common in between these two will be empty set. It is represented as A intersection B, that is equal to empty set. Overlapping sets. 2 sets which have at least one common element. Two sets are set overlapping set which have at least one common. For example, if it is A is equal to 1, 2, 3 and B is equal to 2, 3. So here you can see that 2 is common in between these two. Overlapping sets are those sets which have at least one element common. And their Venn diagram will be like that. A and B. A elements are 1, 2 and 3. 1 and 3 will be written over there. Here you can see 2 and 3 are common ones. So that will be written in the common part. And 1 is the part of A and B is having element 4. And here the A intersection B will be 2 and 3 as well. Next one is subset. If each element of a set is also an element of other set. For example, we are having B is the bigger one set and A is the smaller one set. If one set is contained fully into the other set, so it means that this would be the subset of that set. Here A is equal to 1, 2, 3. So A elements are 1, 2, 3. That all elements of A are there in B as well. So it means that the smaller one set A is the subset of B. And here 4 we will write as the 4 is the part of B and A is fully contained in B. As you see, A is fully contained in B. So it means that A is the subset of B. And the definition says, again, read the definition. If each element of a set A is also an element of the other set, that is here B. So it means that A is the subset of B. A is fully contained in the bigger one set, that is B. Fine. I hope you have understood this concept as well. So there are three Venn diagrams. One is disjoint set, nothing common in between them. The second one is overlapping set, something is common and some things are not common. And third one is subset. One set is fully contained in the bigger set. So this is disjoint. This one is overlapping. And this one is subset. So I hope you have understood Venn diagrams of disjoint, overlapping and subsets. Equal sets, two or more sets which have same elements. Here 1, 2 and 3. Same elements in tabular form. So it will be x is less than 4, all natural numbers less than 4. So it will be 1, 2, 3 and 4 will not be included as it is less than 4. So all above sets are this A, B and C. All these sets are equal sets. Now next one is equivalent set. Two sets which have equal number of elements. Just we have to count either one set and the other set is having same number of elements or not. For example, A is equal to 1, 2, 3 and B is equal to ABC. We don't have to see either both two sets have same elements or not. Just we have to count them. 1, 2, 3 number of elements. Here 1, 2, 3 number of elements. So both two sets are equivalent sets. We can write it n of A is equal to 3 and here n of B is equal to 3. Both two are having same number of elements, so it means that these both two sets are equivalent sets. So let's make the diagram. It's A and it's B. If it is triangle, rectangle and circle. and here it is 1, 2, and 3. Here you can see that A set is having 3 elements and B set is having 3 elements. So these both two sets are equivalent sets, or we can write it down as equivalent set, and this will also represent equivalent set. Fine. Last, universal set. Universal set is a set which is having all elements under consideration. This is that one big set which contains all the subsets. Find, for example, set of whole numbers, set of integers. All other sets are subsets of universal sets. You can see that U will be represented in the rectangle, and all other sets A, B, and C are the subsets of universal set, and they will be written in the circle, and this universal set will be in the rectangle. Fine. All the elements of universal set will be in that rectangle, and rectangle shows that this is a universal set, and the circles represent these are the subsets, and all subsets will be there in the universal set. So we have discussed all the types of the sets. Now it's the time to solve exercise 1D. So let's solve exercise 1D. Its question number 1 is, make a list of finite and infinite set from the following. The first one, set of cities in Pakistan. Can we count cities of Pakistan? Yes, we can count. So it means that this set will be a finite set. I am representing finite by F and infinite by IN. So yes, this will be finite set. Set of universities in Lahore. Can we count universities of Lahore? Of course, yes. So it means that would be a finite set as well. Set of whole numbers. Set of whole numbers are not countable. If it is written set of first 5 whole numbers, first 10 whole numbers, then we can count the numbers. But here set of whole numbers are infinite. So it would be infinite set. Set of negative integers, we cannot count. Set of negative integers again, so it will be infinite. Set of points on the line segment. Here you can see this is the line segment. Here you can see this is the line segment, and there will be infinite number of points on one line segment. So we cannot count number of points on the line segment, so it would be infinite as well. Set of vowels of alphabet. Set of vowels. Can we count set of vowel of alphabet? A, E, I, O, U. Yes, there are 1, 2, 3, 4, 5. Okay, this is a finite set. Now make a list of empty sets from the following. Set of whole numbers between 9 and 10. As you see, the whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to so on. So they are saying whole numbers between 9 and 10. 9 and 10. Is there any whole number between 9 and 10? No, there is no whole number. So it would be empty set. And the second one, set of people who landed on Mars before 1994. This is also an empty set. Third one, set of integers between 4 and 6. Set of integers between 4 and 6 is 5. So this set is not an empty set. Set of even prime is 2. This is also not empty set. Now the fifth one, set of 3-digit number greater than 1000. This is also an empty set. There is no 3-digit number which is greater than 1000. Set of points of the intersection of two non-parallel lines. When the lines are non-parallel, so there will be point of intersection, means this is this will be the point of intersection between the two non-parallel lines. So this will also be a non-empty set. So here is a point. Let's see, this point is P. So P will be the point which is there in between two non-parallel lines. There is no point of intersection between two parallel lines. But if the lines are non-parallel, so there will be the point of intersection between these two non-parallel lines. Now the third part. Make a list of the pair of sets which are equal from the following. Here you can see that A is equal to 2, 3, 4 and 3, 4, 5. These two sets are not equal as they are equivalent. But they have asked about the equal one, so they are not equal. Fine. A is equal to 1, 4, 9 and B is equal to 12, 22 and 32. These are again not equal. These are equivalent. A, B, C, D, E, F and set of vowels of English alphabets are A, E, I, O, U. A 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. This set is not equal but equivalent. A is equal to 2 and set of even prime is again 2. So these both two sets are equal. A is equal to multiples of 7 less than 30. 7 ones are 7. 7, 14, 28. So here 7 is missing. Here 7 is missing. So these both two sets are not equal. Now the sixth one, here there is 0 in between. Here there is 0 in between these two brackets. So A is having a single element, that is 0, and B is empty set. So these both two sets are not equal. Seventh one is A, B, C, C, B, A. Yes, A. Here is also A, B and C. Both two sets are equal. Eighth one, A is equal to N, J, N, I, L, E, M, I, L, E. So here there is N, there is M. So these both two sets are not equal, rather they are equivalent. E, A, T, E, A, T. The ninth one, both E is in A and B are equal sets as the elements are same A, E, E and T. Fine. The 10th one is X, whereas X is an even number less than 4. Even number less than 4 is 2. So 2 and 2, both 2 are equal sets. 11th, A is equal to S, M, Q. B is equal to S, M and Q. Both are equal sets. Now let's move to its question number 4. In question number 4, make a list of equivalent set from the following. The first one, A is equal to number of elements of A is equal to 1, 2, 3, 4. And number of elements of B is equal to 1, 2, 3, 4 again. So both two elements, both two sets A and B are having same number of elements. So these both two are A is equivalent to B. Now see, there are 1, 2, 3 elements. Number of elements of C is equal to 3 and the number of elements of D is equal to 1, 2, 3, 4. So here there are 3 number of elements, here there are 4. So C is not equivalent to D. Now here E is 1, 2, 3 number of elements and F is 1, 2, 3 number of elements. So E is equivalent to F. Number of elements are same. G is the set of counting numbers less than 13 will be, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Less than 13 will be this. And H is the, this will be G. And H is the set of numbers of the month of year from January, February, March, April, May, June, July, August, September, October, November, and December. So here there are 12 number of elements in G is 12 and number of elements in H is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we can write G is equivalent to H. And in the fifth part, there are 1, 2, and 3 elements. So n of I is equal to 3 and n of j is equal to 1, 2, 3, 4, 5, 6. So n of I and n of j are not having same number of elements. So I is not equivalent to j. I hope you have understood this as well. Now let's move to its question number 5. That is, find the relation between each pair of the set A and B, write the result symbolically. Here you can see B is fully contained in the set A. 1, 2, 3, 4, 1, 2, 3, 4. But it is infinite, A is infinite set and B is finite set. So B is the subset of A. And in the second part, A is equal to E, and B is equal to set of vowels of English alphabet, that is A, E, I, O, U. So it means that A is fully contained in set B. So A is the subset of B. This opening will be, this sign opening will be towards the larger set. Here the larger set is A, as this is infinite set, and here the largest, in the second part, the larger set is B. So you can see that opening is towards the larger set. A is equal to PAR, RPA. B is equal to RPA. Both two sets are equal sets. So we can write that A is equal to B. Now in question number 6, write the missing element in each pair of the set to make them equal. If they are equal sets, if we are going to make them equal, so both two number of elements and the elements must be same. So T is there, F is also there, S is also there. So we have to replace it by O. 1, 2, 3, 1, 3, and here we will replace it by 2. A, E, T, T, A is also there, E is missing. P, O, T, 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 and O is missing. So we have made them equal. Now the seventh part, write the missing element to make each pair of the set equivalent. Equivalent means that we just have to make the same number of elements. Elements can be different. For example, if 1, 2, 3 and A, E, any number can be there. Like we can write T, we can write P, we can write S, we can replace it by any element. Apple, banana, grapes, orange, A, B, Z, Y, A, B, C, D, we can write. London, Paris, Montreal, and Kasur, Peshawar, Bhotki, Multan, Karachi, Islamabad, any Any city can be there. Fourth one, 1, 3, 5, 2, 4. 9 can be there, 8 can be there, A can be there, S can be there, P can be there. Just the number of elements should be same. So I hope in today's lecture you have understood the different types of sets and exercise 1D as well, as we have resolved all the question, all the parts of exercise 1D. So thank you for watching my video, and in my next video we are going to discuss some more attributes of sets like subsets, proper subsets, improper subset, superset, power set, correspondence between sets, and cardinality of sets, some important symbols used in the sets, and we will resolve exercise 1E, all questions. Keep watching and keep smiling. Allah Hafiz.